Okay, guys, I just want to talk to you real quick about this idea of negative numbers again, and why and how this stuff works out as we go. And the difference between and or when you're dealing with a negative number. So we kind of ended with this a little bit yesterday, but let's talk a little more about it. As you see on the screen here, we have two problems that are very similar to each other, but there's a small difference. One says greater than -7, and one says less than -7. And we talked about absolute value. We have greater than and less than, and we want to see this. But this is the math of why this works. And this is one of the sticking points we had yesterday. Talk about greater or less than. Well, let's just kind of look at what happens as we go. We first and foremost know that this side is the or, this is the and those are important distinctions to make as we go. Let's start by solving these things. Let's break it up into two cases here. So we have 2x plus 5 is greater than -7, or 2x plus 5 is less than +7. Okay, we just broke up two cases, switch things around, and we solve. Subtract 5, subtract 5. That makes that really easy. So 2x is greater than -12, or, again important, or 2x is less than 2. Divide by 2, divide by 2. We are going to get x to be greater than -6, or x to be less than 1. Well, that's our final piece there. Let's put a graph. Let's graph this. Let's put a number line down. Here's my number line. Okay, I'll put some numbers. So we have -6 is smaller, 1's bigger. And we'll go through our little check marks here. So we're over here right now, and let's pick a number here, 7. And we ask ourselves that same question. Is 7 greater than -6? Is that true? Well, the answer is yes, it is. Remember, since it's or, sorry, -7, that's wrong. -7 is not greater than -6. So that's wrong. But if I go over here, is 7 less than 1? Well, that is true. Good. So I can graph over there. Okay, so let's check another point. Let's pick a point in the middle. In the middle, that would be 0. Is 0 bigger than -6? Well, that works good. So I can check there. All right, so we have the middle done. Let's move to one on the outside now. 2. Is 2 bigger than -6? Oh, yeah, that works too. So that one checks it all. So as I look at this, there is not a single place where I can't graph. There's no x's in there. Every region works. Even -6 and 1 work as well, because -6 is less than 1 and 1 is greater than -6. Those work as well. So everything works. So I have graphs going both ways. Now in this case, because there are no gaps, no breaks, and everything works, we have this idea of all real numbers. That means infinite solutions, or all reals. You can say it either way. Okay? And the reason this works, we think about this for a second. Coming up here, I want the absolute value of something to be greater than a negative something. Well, if we think about absolute value always makes things positive. Therefore, if your absolute value says greater than a negative, a positive will always be greater than a negative. So if you have the absolute value of something is greater than a negative value, if that's true, it will be all real numbers all the time. Conversely, we talked about this yesterday. We have this. You're going to get the same thing. You get 2x plus 5 is less than -7. We're going to end up with x being less than -6, and x is greater than 1. So if I think about what this is saying, and where are numbers that are less than -6 and greater than 1? Well, none exist. So that's why we have no solution. And the same thing goes to here. If your absolute value of something is less than a negative value, okay, if that's the case, you are going to have no souls, always. Okay? Because it's impossible for a positive to be less than negative. Just some number theory there as we go. That's one piece we want to go. The other part of this video I want to ask is this application, kind of how we write these based on story problem. So absolute value is, remember, it's a range of values. It takes you a distance in the positive direction and the negative direction. So if we look at it, says John reads that any fish he wants to keep must be within 5 inches of the previous years. Within, that's important. That means it has to be plus or minus 5 inches of the average. Okay? If last year's average is 16 inches, what is the acceptable range? But within 5 of 16, that means I want distance from 5. So if I have 16 and I add 5, that's going to give me 21. If I have 16 and I subtract 5, that's going to give me 11. So my answer here, okay, if I use L as my length, I have to be greater than or equal to 11. That's my low end. But I have to be less than or equal to 21. Okay? That's this, acceptable range. That's that part. Now, as we deal with an absolute value inequality, remember an absolute value is a distance. Okay? So when we talk about this idea of the absolute value inequality, that's a distance. We have to figure out what my distance is. Okay? Absolute value deals with distance. So your distance is that range. Okay? Your distance is going to be 5 because it's within 5 inches of that range. So as I set this up, the absolute value has to be within less than or equal to 5 because I can't go beyond that because less than or equal to. Right? And what we have to do is determine what goes inside the absolute value part. Well, if I look at that, that's where this 16 comes in. What I did, I added and subtracted x from 16. So I had an x in here, and then I had to deal with the 16. Well, I do minus 16. And so as I take that, I want to make sure that I'm dealing with what my spot in the middle was. So if we notice 16 and 16 goes in here, and then your distance is 5. So that's how we kind of write these absolute value stuff, is know your starting value right here, and then this is your distance I can have. This is your within. So as if I wrote that a little differently here, I would write this here as your starting. It's kind of your starting point, or your middle even is another place to go. And then this guy is your distance from your middle. Okay. So when you're writing absolute value equations, that's the way we can use that information to do it. So if I was to throw a number line up here, and I said, well, let's write an absolute value equation from this. Let's do -8 up to 4. And I wanted to write an absolute value equation that modeled this guy right here. Okay? Well, first of all, this is an and because it's an overlap. So I set my absolute value up, and it's less than. These guys are filled in, so it's or equal to. And throw an x in there. And what we have to do is determine where my center is, so minus, and what my distance is. Well, a center is easy. That's just finding the average. Okay? Your center is nothing more than your average. So I'm going to do -8 plus 4 divided by 2. That's going to give me -4 over 2, which will be -2. So there's my center. That goes in there. -2. So there's -2. That's my middle. Now what I have to do is figure out my distance. Okay? Well, my distance is how far I'm going this way and this way. And if I think about just counting, how far is it from -2 to 4 or from -2 to 8? That distance is 6 either way. So that's my distance there. Okay? And then if we clean it up, minus a negative becomes a positive. And then we have this guy. So this is the absolute value equation for that graph. Not difficult. It's just, remember, you got to find what your center is. That's the average down here. And then you just clean stuff up from there. So that's the kind of the extension stuff we didn't get a chance to talk to you about yesterday, but this will be working with today. So I hope everything goes well. Hope you guys have a great day, and we'll see you tomorrow.